Hi, welcome to Coding Gravity. In this mini course, we'll investigate this concept we call gravity, model its behavior, and determine what physical quantities affect it. To begin, we all know objects fall to the earth if given the chance. The question we're most interested in is why? Why does a glass fall to the floor when knocked off the table? Is being on the ground the solid object's natural place in the universe? Is it because that glass wants to be as close to the Earth's surface as possible? One ancient Greek philosopher thought so, and many agreed with him for 1,000 years. At this point, you've lived long enough on the planet that you can confidently say that objects fall because of gravity. And you're not wrong. Gravity is the reason why this glass fell to the ground. But what exactly is gravity? Many people have thought about this question for a long time. We get our first clue in the 1600s from one of history's most famous British mathematicians and natural philosopher, Sir Isaac Newton. People knew about the concept of gravity long before him, but they thought it was just an Earth thing, meaning something unique to being on the surface of this planet. Newton, however, questioned this belief and connected two seemingly unrelated examples to prove there was more going on here. In one example we're all familiar with, if we throw an apple forward, it will fall to the earth. That's because gravity is pulling it to the ground. In another example, the moon is moving forward, but instead of following a straight line path, it moves in a circle. And Newton realized that it does this because there's a gravitational pull between the Earth and the moon. The moon is actually falling toward the Earth, just like the apple did, but it is moving fast enough forward that it keeps missing the curved surface and continues to fall. In other words, he claimed that the gravity that pulls the apple to the Earth is the same gravity that pulls the moon to the Earth. Let's be clear, when we say objects have a gravitational pull on each other, the scientific term for this is a gravitational force. A force in physics is any sort of push or pull on an object, like pushing on a couch, or a chain that's holding up a chandelier, like your foot pushing against the ground as it walks, or a car's engine pushing it forward, or its brakes pushing in the opposite direction. All of these forces have the potential to cause these objects to gain or lose speed, called acceleration. Newton claimed that everything that has mass exerts a gravitational force on everything else that has mass. Mass is a measurement of how much matter an object has. We now know that there is a gravitational force pulling the apple and moon to the Earth. But there is also a gravitational force between two people that pulls them together. We just can't feel it because it's so small. In fact, Newton hypothesized that gravity doesn't just happen on the Earth's surface, but all throughout space. Every object that has mass is attracted to every other object that has mass. There are gravitational forces all around us. Newton's explanation was groundbreaking. A universal law of gravity. The data of star and planet positions and what we observe from the surface of the Earth seem to confirm his conclusions. However, only 300 years later, another very famous scientist proposed an alternate theory about gravity, but that's for another time. In this module, we're going to investigate the properties of Newton's model of gravity. Now, from our vantage point, we can easily see objects fall to the Earth, but it's a lot harder for us to see how planets and stars are affected by gravity. Therefore, you are going to use computer programming to help develop a gravity simulation that will allow you to explore and test the gravitational forces between objects. More about this in a moment. Now it's your turn to do some reflection and research about gravity, after which you'll start coding your own gravity simulation.